So we're talking hydraulics and pneumatics now. Hydraulics and pneumatics. Also known as fluid power. So fluid is any substance that can flow. Liquids tend to include waters and oils, whereas gases are things like nitrogen, helium, or basic air. Then you also have semi-solids, or what is known as a slurry. There's a lot of different ways you can make things flow. Glass is actually able to flow. You ever seen an old house with a bunch of glass in it? The glass at the top is what? It's thin, just very thin. Glass at the bottom is much thicker. Why? Because glass is a class of its own, but basically it is almost like a solid liquid. It just slowly tends to slump down over time. So, those of you that didn't know that. So a piping system in which a fluid performs work, you have hydraulics and pneumatics. So hydraulics, you have 5 components for each of these. You have to have some sort of, in hydraulics, you have to have what's called a reservoir. What that means is that you have to have some place for it to gather. So think about the oil system in your car. That's hydraulic, right? What do you have to do periodically? You have to check oil. What are you doing? You're dipping that into the oil reservoir to find out what level that oil is sitting at, right? Why? Because you don't want to ever run out of oil. Believe me, it's not good for your engine. You have to have a pump. What does the pump do? It takes the oil from the reservoir and moves it into the system, because otherwise it just sits there. Okay? You have to have some form of a load. Normally it's called the actuator. So again, you have to. It's great to have a system and all, but if you don't have anything doing work, what is the point? Right? If you don't have something to do the work, what is the point? You have valves that help you with the control of it. It helps direct it and move it so that you can do more things with that circuit. And then you have to have some form of piping. Generally with hydraulics, you want it to be very well sealed because we don't like leaks in hydraulics. Why? Because hydraulic fluid's expensive, and B, it can be flammable. You don't want that in places that it does not belong. For pneumatics, we have a receiver. We don't always have to have one of those, by the way. Now, what do I mean by that? Well, if you've ever seen a little work compressor that people carry onto job sites to work with air tools, those don't have reservoirs. They just run all the time. They don't have that receiver to hold that pressure and hold the excess air pressure. What they do have is just a constantly moving engine that is able to compress to a certain point. Does that make sense? So receivers are not 100% necessary. There are several out there that do not have those. You have to have a compressor, however, because if you don't have something to compress air, it kind of becomes useless. You can't really do much with it unless you compress it. Again, you have to have some form of a load in the form of an actuator. You have to have something that does some form of work and uses the compressed power to do something. Otherwise, again, what's the point? You have to have, again, the valves to create control so you can turn things on and off. You can move it left and right, however you need to do. And then you have tubing. Now, this one generally is a lot of tubing. Okay. Questions on the elements, guys? All right. Reservoir receiver. You're looking at a storage space, and it is the starting point for hydraulics, but not pneumatics. Again, because pneumatics, you don't always have to have one. But B, the fact of the matter is, with pneumatics, all you do with a receiver is it's just there to store the excess so you don't have your compressor constantly running. It's kind of like a hot water tank, right? It's there because that stores and keeps the water hot. With hydraulics, yes, that's where it starts because you have the pump that then moves it around the system, right? In pneumatics, it does not start there, it starts at the compressor. The good thing about pneumatics is we can vent it to air. It's why it's one of the most popular ones to use. Hydraulics have to be returned back to the reservoir, just like in your car, because otherwise you have a leak somewhere and you probably need to get that fixed, right? Some different symbols. You have hydraulic reservoirs. These are ones that are vented versus a sealed or pressurized. Okay. Now, the different ways that they're showing you to collect the fluid with the pump. Anybody ever dealt with hydraulics? A couple of y'all? Where do you want your pump to sit? Do you want it to sit at the very bottom of the reservoir, at the very top of the reservoir, or somewhere kind of just barely above bottom? You want it above the bottom. Why? Well, how many of you have ever changed your oil? Well, the whole point is that in any tank, or reservoir, so let's say this is my tank and this is my pump. I don't want my pump sitting down here because that's where all the garbage collects, right? Because what does sediment gradually like to do? Settles to the bottom, right? Just like in the ocean, where does all the sand sit? At the bottom, right? So we don't want to be sucking up nasty crud into our system because that's going to tear our system up really, really fast, right? However, if I set it above that line, I start trying to set it up here, what's going to happen when I start pulling too much fluid into my system? I'm going to run my pump dry, right? You're going to have a burned out pump, which is extremely expensive. So the reason you have to be kind of aware of where that pump sits is because if it collects a lot of sediment, you're going to tear up your system because it's going to gunk everything up. How many of you have ever seen the whole commercial of, this is what your engine looks like after X amount of miles, and it looks like the nastiest thing you can possibly imagine. It's covered in black, thick goo. Y'all know what I'm talking about? That's what happens when it sits too far below. Whenever it actually starts pumping that gunk back in, it starts really thickening it up, right? So what we do is we set it above the gunk, but below the lowest line that you can. That way it continually has fluid to pump, but it is not pumping crap into your system. Okay? So reservoirs and receivers. Reservoirs come in all shapes, sizes, and colors. Receivers the same way. We have a pneumatic receiver over in Millsap that stands upright. If you look at this big guy in here, he's laid out on his side. There are positives and negatives for both. Talk about that later, though. All right, pump compressor. You have to have some way to A, move the fluid, and B, for air, you have to compress it somehow. Okay? So pumps are either fixed or variable displacements. What that means is if it's a fixed displacement, it has a fixed amount of fluid it will push at any one time. Okay? It will never push less, or back that up. It will never push more than what it can. If you start gunking it up, it will push less. Okay? That's why you've got to really take care of it. Variable displacements, however, are the ones that are a little bit strange because you can actually affect the output yourself as to what output you want. Let's say you have a relatively small system now, but you need a bigger system down the road. You might buy a variable displacement, larger pump, and that way you can go ahead and put a small displacement through right now. But when you expand that system later, what do you have? You already have what you need, right? You have what's called unidirectional and bidirectional. Unidirectional is what we generally think of. It's the system in our car that just continually pushes the fluid, right? Bidirectional pushes and pulls that fluid back and forth. So you can put it in forward or reverse. Okay. So fixed unidirectional is the most common. Any other ones tend to start really getting expensive, but if you have to have that for the needs you have either now or down the road, generally investment is worth it. So then you've got compressors with pneumatics. This is the starting point of the pneumatic system. Okay, because most compressors are not run with nitrogen or helium. They're run just from air around you, right? So what they do is they take a large volume of air and they start pushing it together and together and together until it's got the pressure it wants. And then it sends it through the system. Okay? Questions on that? All right. These are some different motors, pumps. Of course, you got your compressors and things. Okay, so I'll go ahead and point this out now. The main differences you're going to find between the symbols for pneumatics and hydraulics. Hydraulics will always have a dark colored in arrow that is generally pointing the direction of flow. Pneumatics will not. Pneumatics is a clear triangle. So if you think about it, fluid is dark, it's visible, air is not. Easiest way to tell the difference or to express the difference. The actuator is a load for a fluid power circuit. You have ones that come in two types. They have linear and rotary. Linear moves strictly in a straight line. Linear line, right? Kind of becomes a very obvious one if you stop and really start thinking about how that one is. It moves strictly in a line. So you have a couple different ones. You have single acting and double acting, double-ended rods, things like that. But the whole point of it is when fluid enters one side, it's able to move in a straight line out the other side. Okay? Doesn't matter which way you apply it, the fluid should move the actuator back and forth. And then we have what's called rotary. Now, rotary comes in two types. You have a partial rotation, so anybody remember the old rotary phones? That's a rotary, okay? It does a partial rotation. It does not do a full 360. It does might do like 300 degrees, but it won't do a full go around. Once you get it to the right place you want it, and let it goes right back to where it started. That's rotary. Versus rotating, which is a motor. So the motor is this guy right here. The little pneumatic motor. And he's able to fully spin 360. And when you put air to him, he just does not stop spinning. Okay? So this is what we mean by a pneumatic motor. And no, they don't generally put out a lot of torque. When you're talking hydraulics, those things put out a lot of torque. That's what it needs to do. You find them frequently in mechanic sets. Right? Have you ever had to go get your car's tires taken care of and they go pull out the pneumatic gun and go zoom, zoom, right before they pop that sucker on your tire and pop the lug nuts off? That's what it's using as a pneumatic motor. All right, so these are some linear ones. And then these are rotaries. So this one looks like a motor. That one looks like a motor. These two might be partial rotations. I can't tell. So symbols. So again, you have a couple different ways you can set these up. The whole point of it is for these are linear. What does that mean? It means it needs to move in a straight line. Most ones, I will not say all, most of the ones that are a single acting cylinder have a spring either on the front or on the back. And that is dependent upon whether I need to hold it in one position or the other. Double acting cylinders will have two inlets, and what their whole purpose is to shift themselves back and forth depending upon where you put that fluid. Does that make sense? Okay, and then this one is a double rod, has two rods to it, so it has the ability to shift itself back and forth, but this can push and pull loads on both sides. Okay. This one's a rodless cylinder, so what this one can actually do is you can mount a magnet and use it to move things. You can mount something else to it and use it as a way to stop and start things. Okay. Now then, I will go ahead and point something out. So I'm going to go back a few pages here. So I want y'all to look really closely at the symbol for the pump compressor versus a motor. Okay, so that is your pump and compressor. What is the difference between these symbols for pump and compressor and the ones for a motor? What is the difference between those two symbols? Huh? Not so much the placement of the triangle, because if I really wanted to, this was the right type. The one on the bottom are the motors, the ones on the top are the pumps and compressors. But what is the difference in the symbol? No, that just means hydraulic versus pneumatic. It's the direction of the arrows, gentlemen. The direction of the arrows. With a pump or a compressor, you are pushing fluid out. With a motor or a rotary something or other, you're pushing it into it. Okay? That is, these guys right here, these triangles are the key to this. There means that there is a difference. With a pump or compressor, you're pushing. You're taking the fluid up and you're pushing it into the system. Okay? With a motor, just like we were talking about the air tools a second ago, what are they doing? You're pushing air into it to get it to run. Okay? You're pushing air into it to get it to run. So that is the difference between the symbols. Pushing, receiving. Does that make sense? You're pushing or you're receiving. If you're pushing, you're a pump or motor. If you're a pump or a compressor. If you're receiving, you're a motor. All right? And yes, that is a hard and fast rule. I cannot think of a better rule. Okay. All right, guys, so valves. With valves, we have the whole purpose of these is to stop, start, move, and change. Okay? All they're supposed to do is move and change the direction of the flow of fluid. All right. All right. So you're good. All right. So valves. The whole point of a valve is to control the fluid and move it where it needs to be. Because do we always need a cylinder to be extended? No. Sometimes we need it to retract, and sometimes we need it to do something different. So the whole purpose of valves is to do so. So the operation can be manual, it can be mechanical, it can be electrical, it can be fluid. So in other words, we have several different ways to make this happen, either in person or remotely. Does that make sense? So the way we identify these is we do look at the type of fluid used. Is it a hydraulic or pneumatic? Again, hydraulics have the colored in arrows, pneumatics do not. Number of ports, okay? It's also known as the number of openings or the number of ways. Ways is looking at how many different places does fluid enter and exit. We look at the number of positions the valve can be put in. And then we look at how it's controlled. Just kind of show you all here. Okay, so looking at these valves, these are all pneumatics. I'll go ahead and tell you that now. So what I'm looking for when I'm looking at these valves is, first of all, what kind of fluid is being used? I know these are pneumatics because I just pulled them off a pneumatic trainer. Secondly, how many ports does it have? Generally, on most of these, some of the ports can be hidden. Why? Because they're the vent ports and we don't need access to them. Does that make sense? Okay. So these, I've not only got ports 1, 2, and 4, I got 5 and 3 that are hidden behind these, and those are just vent ports. What they're meant to do is just push air out whenever they're done with using it. Does that make sense? So look at the number of positions. I've got a switch here. I've got position 1 or position 2. This guy right here has position 1 or position 2. This one is this is a remote valve. Generally what you're using this for is whenever the piston hits it, it depresses, and when the piston's off it, it releases. Does that make sense? This is just a little 2 position. Another little 2 position, this one's just a push button. This one is a pneumatically controlled. Okay? So this one still only has 2 positions because pneumatics, we don't always have to have a 3rd position. Hydraulics will generally have 2 to 3 positions. Pneumatics can sometimes just stick to 2. So this one, looking at this one, I have still got only 5 ports. I've got 2 of these that are blocked off, and then I've got these 2 and this one. These 2 ports right here are not technically ports that air will come out of. Because these ports right here are how we move the actuator inside this. Okay? So if I was to draw this particular symbol, first of all, it's got 2 positions. And I call it air actuated. I know it's a terrible drawing, but forgive me. And then the way it comes in normal position, the secondary position, second valve, and then I've got one section teed off. So I've got 5, 1, 3, 4, 2. Then the secondary position, okay, you get the fifth one. So what this is basically for a valve is that these two valves we have, it's called 14, which means that it's going to move air between 1 and 4. And then we have valve 12, which means it's going to move air between 1 and 2. Okay? So it's looking at the number of ports that are open, the number of positions, and how it's controlled. Is it looking at a switch? Are we looking at a pneumatically controlled? Or are we looking at a mechanically controlled? Okay? Does it make sense? They can be controlled a million and one different ways. So looking at the valve openings, how do they line up to change direction of the flow? So we've developed the symbol by combining parts. So we can identify known, unknown symbols by separating the parts of the system. I'm sorry, the parts of the symbol. Let me erase all this. All right, so when we start off looking at a symbol, the way we start off are with the blank squares. We're looking at how many, first of all, how many positions are on this valve. Is it 1, 2, or 3? I don't really know of any that go up to 4 positions. There might be a couple out there, but those would be a specialty set. So once I figure out where everything has to go, I got to figure out what my pressure port is. Am I moving things to tank, or am I just simply venting? And how many outputs I have. Okay? Then I have to determine what they do at each point. For this particular valve, this is actually a hydraulic valve. How do I know? Because that right there means tank. That means pressure, that means tank, which means that I've got to push this back to my tank, or my reservoir, if you will. So this one in particular has 3 different positions, and it has a spring to push it back into position once you take your hand off it. Okay? Position 1, you have your fluid flowing from 1 to tank, and pressure being put to 2, port 2. In position 2, there's no pressure being used. Pressure is held at pressure, tank is capped off, 1 is capped off, 2 is capped off. In other words, you have no fluid moving. Does that make sense? And then position 3, my pressure is going to port 1, and port 2 is draining to tank. Does that make sense? Position 2, it could be that you just took your hand off it, but you don't want your actuator to move just because you took your hand away. Does that make sense? It's a neutral, yeah. It's a way of, okay, I need my actuator to stay there for a minute because it's got to hold position while maybe another actuator comes in and bends a piece of metal. It's just a way of saying, okay, this stays here for a second. I don't want it to lose pressure because I took my hand away. But at the same time, I don't need it to continually add pressure. And then all combines down here at the bottom. to the single symbol. Okay. So the biggest way we move this stuff is through tubing of some sort, piping or tubing. So lines are used to show both pipes and tubes. It shows the direction of flow, shows connecting lines, crossing lines, and how the lines are connected. Now, most of the time in pneumatics, how they connect is very, very simple. With pneumatics, for the most part, it pushes to connect, and then you push and pull to release. We don't have a lot of permanent connections with pneumatics. Why? It's not necessary, right? How many of you have ever dealt with air tools? You want to constantly be able to change those out, right? So with pneumatics, most connections are not permanent. And understand, I said most, not all, because there are some situations where you might need a permanent connection. But a lot of situations, you don't. Now with hydraulics, on the other hand, hydraulics are a horse of a different color. Why? Because hydraulics have a really bad habit of breaking seals and escaping. Think about how many different times you've been driving a vehicle and the oil starts leaking everywhere. It kind of sucks, right? So the way we've dealt with that in a few ways is things like having threaded ways that we connect them. You know, have any of you ever done any plumbing work or installed a shower head? What are you supposed to do? You plumbers tape the crud out of it before you screw it on. What does that do? Is it creates a seal and a barrier so that water can't just get back up in that screw threading and flood everything, right? That's why you got to have that plumber's tape that always seems to never want to rip or anything else and always seems to be a little bit messy. Kind of feels like whiteout tape too, if you've ever had to deal with that. So welding is what we do with a lot of this. Soldering, we do a lot of it. Why? Because these are permanent connections we don't want coming apart. So if you ever got into the walls behind your shower or a bathtub, all that stuff is soldered or welded. Generally soldered. Okay? Welding is one of those things that you kind of save for really big applications. Soldering is the quick down and dirty method. Get it done, get it over with, and you're gone. But threaded pipe is a big common one. So that's the different ways we connect for hydraulic. Any questions on that? And I don't know if it's still page 91. I need to get an updated book, but you need to start looking at the symbols on the last pages of this particular set and just kind of be able to bookmark it, I guess, because I can pretty much guarantee you some of that will be on the next test, guys. So bookmark it somehow, some way, put a flag on it, whatever you got to do. Y'all have any questions on hydraulics or pneumatics and their symbols? No? All right. Then don't forget that Monday, let me stop this real quick.